Mr. Larsson, I presume.
Yes, I feel thankful that I'm here to welcome you, Mr. Donut.
We are two seasoned software engineers, and in this podcast, we're talking about what makes code high quality, communicating the intent to the other team members.
Just a quick note, if you feel like this podcast is helping you in any way, please consider supporting us over at patreon.com/codiscommunication. One word, no spaces. The link is also in the show notes. Thank you.
And today we are talking about types as means of communication. So, that's gonna be fun.
Indeed. I think we have established there's a slight difference between us. You're more the Python, C++ guy, and I'm on the Java side of things. And especially for Python, there's something lacking, isn't there, with regards to types?
No, Python is a statically but not strongly typed language. And you can use type hints.
Yeah. True.
And of course, C++ is quite the opposite when it comes to types. Of course, the idea with using types as means of communication is, I think, pretty obvious, isn't it?
Yeah, if you want to look at histories, I believe it started already in the 50s with Fortran, right?
Well,
but physicists needed to distinguish integers from reals.
If you just have a few built-in types, that's not already a means of communication, is it?
No, but then we had Algo 16 Pascal, where they had types actually used to communicate intent to other programmers. That was actually already strong typing.
Yeah, it's not only about strong typing, it's also about being able to define your own types and give them names. Like we had that in C with structs, something like that.
Yes.
I think Pascal had something similar as well. I don't remember how it was called.
Yeah, my only interaction with Pascal was actually on the Macintosh in the 80s. That's a long time ago.
Yeah, my last interaction with Pascal was on the C64.
Oh, okay. I never touched Pascal on that one, no.
Yeah, so that was long ago. Pretty much all languages that are still in use have some way of defining types, be it classes or in C structs. Somehow you can define types, and in some languages they still feel like not particularly natural, like for example in C, and in others you can make an effort to make them feel like native types. Like in C++ or in Python that's possible.
Actually less so in Java, but close enough, I would say.
Well, can you overload the plus operator?
Exactly, but I was saying close enough.
There is actually one class in Java where the plus operator is overloaded. String.
Yeah. Which you should never use, actually.
Yes, but they did overload it for this one class.
Mm-hmm.
But you cannot do that with your own types. Anyway.
You could. There are arguments why you shouldn't be able to do that with fundamental operators, but
but basically the most important argument is probably you can misuse it and create unintuitive APIs. But you can do that with everything. You can write a function called add and multiply inside. So
that's true. But in the end, it depends also on if you're in a good team, it's not a big risk at all. But if you're in a slightly less senior team, you could have issues where not all team members are on the same level or the same frequency when you talk to each other. So, if you can avoid errors in that setting, there's also a positive side to not allowing too much interference with the fundamentals.
Yeah, but with every way of allowing people to name something, you have the same issue. Sometimes simply operators are more intuitive and more expressive. For example, if you have object A plus object B, at least if we assume that it's a natural implementation, we understand that A and B won't change and the operation will return the sum.
Yeah.
But if you have, for example, A.add B, it's unclear if the operation will change A.
Yeah, then you need to document it, of course, yes. I mean, this is a very common source of errors, to be
Exactly.
very clear. I mean, it's not intuitive to everyone what's happening all the time now.
Yeah. But coming back to using types as means of communication. So basically, I think we're again at the big issue of naming.
Yeah.
Because types can communicate your intent if you manage to name them reasonably. And if you do, you write kind of sentences like, my car is a car. Red and... Actually, my car isn't red, but that's not the issue. So, Your
little red Corvette. Yeah, my car is a vehicle that has 4 wheels in a diesel motor.
Well, my car is a variable. Now, if you use vehicle as a class name...
A superclass, yes.
Yeah, but the derived class would be car, and my car would be a variable of car, wouldn't it? Reasonably. So when I think about it, that's how I meant when I said my car is a car. Red, that's the constructor parameters then. I think it helps to write something that is intuitively understood by every reader. If you have good names, of course. It's always the same.
Yeah, naming is very fundamental.
Yeah.
With the types as communication, you could say that you layered it into 4 different layers. I mean, with the types, you communicate with yourself or your future self. That's the first layer. And the second layer then would be communicating with your teammates. And the third would be to other systems APIs. And the fourth and final one to the machine and tooling you're using.
Yeah, that's a very good thought. Can you elaborate on each of those layers a little bit?
Sure. So if we address the first layer, then it's pretty true that if you use the types to communicate with yourself, it's like a cognitive scaffolding. I mean, they force you to articulate invariants you would otherwise carry in working memory.
Mm-hmm.
And also, it helps you in the future when you look back at your code. What did I mean? What did I intend to do here? And what shouldn't be done in this situation? So that's very basic then. And then in the layer 2, we have the teammates. I mean, I think this one is pretty obvious. I mean, just as you communicate with yourself and help your future self, you help your current and future teammates to understand what you're doing or intended to do.
Mm-hmm.
And then if we quickly go to layer 3, that would be to other systems APIs. I mean, the basic example here would be if you have a microservice architecture, then you need definitely types to communicate governed by your schema. Say you have an open API schema or whatever. And then it definitely helps if you have types defined in there.
I thought you were talking about microservices.
I mean, that is the trend in Switzerland at least. So everything has to be a microservice architecture.
Yeah, even if it isn't.
There's no way getting off. No, but then the fourth layer would be the machine and tooling. And some would say that the compiler is the most honest reviewer you'll ever have. It never gets tired, never has a bad day, and it forces you to make every assumption explicit.
Mm-hmm.
So there's no way, or there are ways to get around it, but it's more difficult than when you're talking to your teammate. So that would be the 4 layers then.
On the other hand, the compiler doesn't care about your names as long as they're distinct.
You're correct. Totally correct on that point, yes. So that's one layer then where naming is less important.
Mm-hmm.
And to summarize in a way, you could say that there's a pattern to this.
Didn't you have another layer?
No, 4 layers.
Okay.
So the first layer is to yourself, future self. The second is teammates. Third is other systems, APIs. And fourth is machine and tooling.
Okay. I was somehow thinking about the communication with the domain experts, but in that case, you rarely use types, do you?
I mean, it depends a bit on the technical level of the business person, but normally you wouldn't use explicit types, no.
The other way around, the communication with the domain experts will influence your choice of type names.
That is true, yes. Or it should be true.
Yeah. If not, you're doing it wrong.
But just to summarize this thought about layers, all of them are about making the implicit explicit, right?
Mm-hmm.
It's a certain form of articulation, and you could argue that this raises the entire team's cognitive baseline if we're stuck on cognitive issues. So it's less about catching bugs. I think it's more about preventing a lot of unnecessary questions from ever having to be asked.
Yeah, but that also avoids bugs, because when people don't have to ask questions, they...
Yeah. No, that's true.
People start programming without asking questions when they should.
That's also an art then, really, when you should ask and when you shouldn't.
Yeah.
But it's also a level, often it comes down to personality. Some people just learn a lot from asking questions, even if they're obvious or should be obvious.
Yes, that's true. But some people don't ask questions and just assume, like in AI. For them, having good names for the types and basically everywhere helps so that they don't go too far off the track.
Indeed, yes.
When I prepared for this, I thought a lot about typing in Python, because even if you have type hints, they are hints, they are not enforced.
Yes, I mean, I have a certain level of experience with mixed code bases where we use both Python and Java, for instance, and I would say that we had quite a few instances where we had bugs in Python simply due to the lack of strong typing. But
yeah.
Yes.
So
I'm expecting a counter argument here.
Well, I couldn't come up with a real counter argument now, but the thing is, it's even more important to write type hints because you at least tell the reader your intent. And there are tools that find places where you use the wrong type when you call it and stuff like that.
Yeah, I think a lot of people are working with web applications have for sure used Pydantic, for instance.
Yes.
It's already very helpful.
Yeah.
Saves you a lot of time in the end.
Well, programming, yes. At runtime, Pydantic can be very expensive.
That's also true, yes. It's always a trade-off.
Yeah, so you have to know that you actually profit from what you're doing there. So if you actually convert to JSON and back, and if you actually have to validate input, then Pydantic is great. But if you use that somewhere inside of your application where you don't have to validate stuff, then it's usually just eating your performance.
True.
Which brings me to another point, and that is compiled versus interpreted languages. Because in C++ and also in Java, all the type stuff is mostly interpreted at compile time. So at runtime, you don't have any overload.
That's a very good point, yes.
That doesn't mean you shouldn't use interpreted languages. It's just another notable difference. And it's also not only a difference in performance, it's also a difference in when you learn about bugs. With Python, it often happens that you learn about bugs when the application is actually running. At least when you don't have good tests. And pretty often you just miss one or two cases. In dynamic languages, you learn pretty late about your bugs. And in compiled languages like Java, C++, Pascal, the wrong types are
caught earlier.
Yeah.
But in the end, I mean, then we get back to another trade-off is that with languages like Python, interpreted languages, you tend to develop a lot faster. I mean, this is perfect when you're in the proof of concept stage, where you just want to quickly find out if it's possible at all on a conceptual level. And then you could just as well implement it in say, Java or C++, if you care about performance.
Yeah, actually, many projects do that.
Yeah.
Even after the proof of concept. So when you do a minimum viable project, you write it in Python or JavaScript or whatever.
Yeah.
And then when the project grows and has more and more users and performance is more and more cost factor, you start to port one or two components over to C++, Java, Rust, whatever, Go, whatever fits the bill there.
Yeah, true. I mean, there's also a very common setup where you have the domain experts. Let's say they are quant experts and they can express themselves freely in Python, but they are less keen on doing or implementing computer science principles every day. So instead they leave this to the IT departments where they implement the ideas in, let's say, Java then or C++.
Yeah.
That's also a very common division of labor, so to speak, that you have the researchers, whatever field it may be, that they express themselves in Python, and then IT specialists take care of the execution, so to say.
That's a very specific thing about the Python world. That's true. Because I don't see similar things in other interpreted languages like, I don't know, PHP or Perl. They never had this kind of recognition as Python as a language basically for the domain experts.
Yeah, but I mean, my basic stand here is that Python is a lot easier than PHP or Perl. I mean, easier for one who isn't a trained programmer, I would say. It's more straightforward.
Yes, yeah, no.
To a fault.
Yes and no. For someone who writes web pages and just needs a little bit of dynamic PHP is great.
It is, yeah. But it's also interesting because it used to be very forgiving also to a fault, but it's moving, as we mentioned in earlier episodes, it's moving towards object orientation, and it's
true, yeah.
Becoming more and more of a mature language for good and bad.
Exactly.
Elevates the threshold to get into it, I would say. And another point for Python is also that it has such a vast set of libraries, especially for natural sciences like math or statistics or what have you.
Yeah.
So it's very easy to get quickly up and running and testing your hypothesis in a very user-friendly way.
That's true, yeah.
And then in the end, you tend to or might run into performance issues. But again, if you have a good division of labor, that's not an issue.
Yeah, basically, that's probably the best use of languages like Python, though I'm writing whole applications in Python as well. But in that case, it's like I said before, I'm writing a minimum viable product. Yeah. And when it actually takes off, then I can invest in improving single parts of it, which are the most performance critical ones.
Yeah, the bottlenecks, yeah. That's good. Keep doing that.
Well, I am.
Very good, very good. I mean, we could also connect types to AI. I mean, everyone wants to hear about AI these days. So, I mean, if you have very good specified types, if your types are very well specified, it helps you to communicate with, say, an LLM, for instance. So it limits the room for hallucinations, etc. So even in this new era of vibe coding, you're still helped by having good types.
And that's actually pretty logical because the LLM works with language. When the LLM reads the word car, it thinks, well, it doesn't think, but
it
uses it as if it was a car. And if it reads class 35, there's nothing that it can do with it. So when you have good type names and other names, it's easier even for an LLM to understand that code and explain it to, for example, a new team member.
Whether your new team member is a bot or a living individual.
The funny thing about this is that the AI is pretty bad at choosing names. When I work with AI, I always have to change generally the API to something that is easy to understand.
I see, that's a good point, but I actually heard a colleague of mine who said that Claude was very good at naming, or it didn't get in the way at least.
That's interesting because I haven't worked with Claude yet. I've experimented with a few others.
But I think it's starting to shape up like Claude is the current leader in terms of if you want to use AI for programming. So it might be worth checking out. I mean, I also need to check it out too.
I've had a project where we used Copilot.
Yeah.
And I have experimented with local models. And I've experimented with ChatGPT. To wrap this all up, finally, if you're getting value from this podcast and would like to support it, you can do that via patreon.com Code is Communication, just as one word. And the link is also in the show notes. That would help us to keep up the work on this podcast. And we would also be very happy to receive any kind of questions, comments, or any kind of feedback on the topic. You can reach out to us on our social media channels, and that is code-is-communication on Facebook and LinkedIn. It's the same with underscores, so code_is_communication on Instagram. On Blue Sky, it is like our domain name at code-is-communication.fm. And on Mastodon, it is at cic-podcast@hostsharing.co. If you still prefer X, you can find us there as at code_is_com with 2 M at the end. And we also have an email address, and that is cic@code-is-communication.fm. Okay, everybody. Take care. Bye-bye.
Take care. Thanks for listening.